bring this concept of distributed databases home, there's a diagram here that will help us maybe focus on the advantage or why we really need a distributed database. So there's this an app here, payroll app, that is actually within within London site. Then Hong Kong also uses the same app, same to New York, right? So we have a centralized kind of a database within London, which needs to be accessed from other sites. So you can see here, someone is saying that they run very slow, right? We are going to see how to maybe make this thing work. And that's why we require to understand how a distributed system, distributed database works. So we need to replicate. We need to have this database within London, closer to New York, and of course, closer to Hong Kong. We are going to see or what makes it important for us to have multiple databases. So you can see this access is happening by the internet. So I think one thing that comes into mind is the slowness. How is your internet, for example, right? Is the link towards the main database up and running all the time, or we have the latency and all those issues? So those are things that can contribute into the slowness of this accessing this particular database. Now, this other diagram, you can see now the same database is now replicated. I tend to use the term replicated just to have the understanding of multiple databases across multiple sites. So you can see now the data or the database that was in London now within New York, and also it is within Hong Kong. Now, this is distributed database, right? We had the main database in London, but now, since of the slowness, we want to remove these bottlenecks that the centralized application brings on board. So you can see the payroll app is now closer to the Hong Kong users. It also is closer to the New York users, right? So that means even if the London database maybe has issues, they can always use the available data closer to them. But again, you're going to look at some of the bottlenecks that this particular setup brings on board. Now, when we replicate or have different fragments of data in multiple sites, it brings some kind of advantage. And this advantage also can lead to some other unforeseen disadvantages. Maybe the first advantage is that we can maybe execute other additional applications in parallel, because here performance is enhanced, right? We have data being accessed across multiple sites easily, right? So we can always have multiple or parallel executions of applications, right? So this is just an example of how the concept of distributed systems or database works. So as I mentioned, one advantage of a distributed database system is the concept of providing transparency. So the user here should not really be bothered on the kind of databases that are implemented or database systems that are implemented. As you can see, there's a diagram here showing different, we are assuming that different sites run on different database management systems and so on. So one aspect that we need to understand here, or the advantage, is that it offers some kind of transparency, right? So this particular transparency is what we refer to as distribution transparency. A user in Nairobi, for example, if the main database is in Mombasa, they should not really think about the underlying network or the underlying database management system that is implemented in Mombasa, all is that they get that particular data that they require. So distribution transparency is very, very crucial, or it's one of the advantages. And I think this transparency has been talked about, maybe looking at the operating system, middleware offers this kind of transparency. So the same way within this distributed database systems, sorry, we normally talk about a single view known as conceptual schema. Yeah. So this conceptual schema normally offers a transparent layer, right, to the user, so that they are not really exposed to the underlying database management systems or everything. So how do we then perform this transparency? This transparency can be established by what we refer to as data fragmentation and replication. I think ideally, we are going to just mention briefly the two categories of replications. The two categories of fragmentation. We have horizontal fragmentation and vertical fragmentation. A good student who understands how a database is actually developed, designed, and implemented, you need to understand that we have the records that are normally stored within the tuples, and of course we have the various fields captured as columns, right? So when you have the main database, we can always replicate or fragment, divide the different parts of the database and actually replicate them, right? And that's what is shown across these particular sites. So within, we have the Chicago main database, right? That also is replicated across the other sites, which is Atlanta, San Francisco, and the rest, right? So instead of Atlanta people going direct or accessing the Chicago database, they can always have the data closer to them through replication and fragmentation. So these are just some terms to understand that, understand how we divide parts of database across the network, right? So that if there's a problem within the link, right, and so on, we can always avoid that, right? Talking about transparency, also can bring on board the network transparency, right? I think in our previous discussions, we talked about the different categories of transparency, right? For the sake of time, I think I won't really tell you to name them, but there were like 7 or 8 transparencies that we talked about, right? Access transparency, migration transparency, allocation transparency, naming all these forms of transparency are very, very crucial, when we talk about any given distributed system. And in this case, we're talking about a database, right? So like in this network transparency, users do not have to worry about these details. I think I've always mentioned about this. Users do not need to worry. Yeah. Like for example, there is allocation transparency, yeah, where you can always execute the various SQL commands, yeah, from any site without really affecting the underlying operations, right? Like we have different categories of SQL commands. I believe we understand the DDL, DMLs, and DCLs, right? And of course, how we name our objects. Like for example, when you want to set up your various attributes and entities within a database, they are always conforming to a particular standard, right? So this is what we refer to as naming transparency. So as we replicate and fragment the different entities and attributes, the same, they should have the same naming convention across the different different sites. And that's what we refer to as naming transparency. So that let's maybe look at the advantage of this, right? In naming transparency, if something happens, for example, let's say one entity is corrupted and maybe there's an update issue, yeah, so we can always track the same entity using this standard name, right, to the exact entity or where this particular issue occurred. So these are just advantages of it. And of course, replication transparency. When you replicate or have data across different sites, right, it should actually not have issues, the user, as we had already indicated in our previous diagram. Also, we have fragmentation. Fragmentation is where now you go record by record and column by column, right, to really understand how the various data types are used and so that if you fragment this particular data, then they appear to be the same, irrespective of which database is handling them or which site they are. So these are just concepts of distributed database system that contributes their advantage. So you can see that the main advantage that this distributed database system brings on board is transparency. Transparency can be achieved through replication and, of course, through fragmentation. And, of course, how we allocate this data across multiple sites. So what then, or how then do we maybe utilize these replications and fragmentations of data? So we'll have increased reliability and availability. It's common sense. If you have multiple copies scattered all over, right, then availability of this data is going to be actually enhanced, right? Because if maybe one copy gets corrupted within a particular site, you can always have the better copy on these other sites, right? And the same thing, reliability, so that to ensure that the system or the user can always get their data anytime that they're accessing this particular database. And of course, we know that if one link fails, like we have looked at the multiple sites, we can always get or redirect the user to use a particular database that is closer to them. So these are just added advantages. Another one is improved performance. The time it takes for a Hong Kong user to maybe interact with the New York database is a lot. And there are a lot of factors that are involved, right? So when it's brought closer to the user, then actually it is easier to access. The time that it takes to access this data also is reduced, right? And of course, it also enables easier manageability, right? Scalability issue is also enhanced as another advantage of having a distributed system, right? In that you can always add, as you add new sites, can always replicate data anytime that you want, as long as the site can accommodate the operations that needs to be executed. So I think we can go on and on talking about these advantages. But the key advantage of a distributed system is to be able to push data across multiple sites, right? So that we don't maybe use a lot of time accessing a particular database that is far away. So here, the concept of replication fragmentation cannot just happen in isolation. This database that we're talking about should be or should have some kind of relational data model, right? So that's why I say that, again, just like other previous discussions, when we talk about operating systems, we needed to have just some little bit understanding of how an operating system functions. We looked at networks. We had to have an understanding of how networks functions and so on. So here we are talking about distributed database. So again, we need to understand just some concepts of databases, like the models. I believe we have hierarchical models. We have, apart from relational, we have hierarchical. We also have, there's this one that is escaping my mind. There are normally three, yeah, object-oriented models and so on. So Replication can only happen when you have this related data model, right? So that if we replicate or fragment a particular data, we can always relate it. Now, advantage of understanding or having this relation data model is that we can always, when we push some updates, maybe from the main database, right, automatically, yeah, it can be pushed to the respective fragments without any issue. And that's the importance of relational. Remember, relational, we have the unique identifier. So if you have this unique identifier and foreign keys, it makes these replication and fragmentations very, very easy, right? Then we also have the data location, which also happens just the mere understanding of how this data is replicated, right? So that at least we can always track. You see, the main concept here of pushing this data is that should there be some kind of concurrency issues that you're going to look at, can we be able to track and roll back the transaction? Let's say, for example, the New York headquarters database was pushing or fragmenting data to across these multiple sites. In case something happens to one site, you see, we can't have like a New York database replicating data across multiple sites, and one site has a different copy of data. That is not allowed in distributed databases. Either all the sites get all the fragmented copies of data, or all of them doesn't, right? So that's the importance of having to understand how these multiple copies of data moves across. So we're going to look at concurrence control, yeah, because you can always update or roll back, right? Any failure of a particular data to be replicated or rather fragmented properly. And that is a concept that really needed to take home in any distributed system. Because, for example, if you look at, maybe let's look at how you operate your bank account, right? If you perform some kind of withdrawal, maybe let's say you are in a Nakuru for that matter, you withdraw some 5K from your account, less, right? It should actually, if your data is replicated in some system, that withdrawal should happen or should be updated across any system that has your details. But is it appropriate that maybe if you withdraw your 5K from Nairobi, and then if you come to, maybe let's come to Nairobi, and then from Nakuru, and then you come to Nairobi, you still find that maybe it has not been updated. So that's an issue that needs to be addressed when talking about concurrency. So we have really looked at this, that a relation or fragment of a relation is replicated, is stored redundantly from both sides. Full replication actually happens when all the multiple sites get to do it, to be replicated. So advantages of this: availability, right? I think this one we have already mentioned about this replication. Execution of multiple processes under several nodes, right, in parallel. Also reduced data transfer, right? So you can see this is a set of relations. So this means that any instance of a tuple, any instance of a field or a column should be replicated effectively, so that at least when we are performing, let's say, some update, the update should be done to all those particular sites. Now, as I said, that all these are good, but also there is a downside of them. It's costly. Replication, as you can see, it requires powerful softwares to handle that. Networks, good networks, right? So it's very costly, and it will often leads to some kind of inconsistency that I've just mentioned, right? So normally it's recommended that we have a master database, right? Normally referred to as where we store primary copy of data. So that if there's something that happens during maybe replication or fragmentation of data, then we can always move to the headquarters, or rather to the primary site, and get the original copy of that particular data. I think as IT guys, you know the importance of having a primary site, right? So that if something happens, we can always roll back and commit another transaction fresh from the main site.